Right. Hello and welcome. We are going to give it just a few minutes to let some other people join, and then we'll go ahead and get started. All right, we still have some people coming in, so we'll just give it another minute. Let some more people join. All right, I think we can go ahead and get started now. We'll do a quick intro and then we'll jump into our webinar today. But welcome to our GridPoint webinar on resilient and sustainable commercial buildings, pathways to decarbonization. We're very excited to have Mike Ratliff, our GridPoint's Chief Technology Officer, as our featured presenter today. He's going to explore pathways to accelerate decarbonization in commercial buildings. My name is Marcia Degnan. I'm the VP of Marketing here at GridPoint, and I'll be the moderator. Before we begin, just a couple housekeeping items to go over with you. Please use the Q&A feature located in the menu at the bottom of the screen to submit any questions at any time during the presentation. We have set some time aside towards the end to answer any and address any of your questions. If you're experiencing any technical issues during the presentation, please send a message via the chat feature directly to myself, and I'll help you troubleshoot. There are poll questions throughout. Please take a minute and fill those out. We will prompt you when it's time for a poll and give you time to answer. The poll will automatically display on your screen. And the answers will automatically display on the screen after the poll is completed. Lastly, we are recording today's presentation. The on-demand version will be available on our website within the next few days. All right, to get started, I'd like to take a second to introduce Mike Ratliff.
Hey everybody, Mike. We look forward to having this chat here. I've been with GridPoint coming up on 2 years now, but been in the energy space, so this distributed energy space, about 15 years. And in the technology world, about 30. So I'm super passionate about this, and yeah, excited about having a discussion today.
Great. Thank you, Mike. All right, for today's agenda, we are going to be kicking things off with a few common misconceptions about decarbonization and carbon neutrality. Then we're going to move into the benefits and process of moving from dirty energy to clean energy. Finally, we're going to wrap up this presentation with an overview of the impact of the energy transition on commercial buildings. So with that, we will go ahead and get started. Mike, when we talk about buildings, they are, they're not merely static structures, but are significant contributors to global emissions. Understanding the concept of decarbonization and its application in buildings is critical. But what exactly does decarbonization entail, and how does it manifest within the context of the built environment?
Yeah, I think there's this, interesting terminology thing happening where not everybody is, 100% in agreement of what some of these base terms mean. And this, I think that slide you've got up really maybe hits on one of those ones that's a common misconception, this decarbonization versus carbon neutrality. And the way I like to think about it, and it's nothing special, is that, decarbonization is actually the more of the, I think, the goal that we're all trying to drive towards, of actually limiting the amount of carbon that we put into the atmosphere, where you might be able to think of carbon neutrality as more of a stepping stone to decarbonization, where we have other tools available to us in the carbon neutrality world of being able to offset some of the emissions that we're doing, which I think is a great starting place, and maybe some place where companies can start to find out what their carbon footprint is. Even if they're not stopping from the emissions side of things, they can start to build out a kind of a roadmap of where their highest carbon footprint is, maybe do some interim offsets and things that can start them down this path. And that can kind of build more of a roadmap towards what a true decarbonization strategy for their footprint might look like in the long term.
Great. Very good answer. Thank you. The second question really is around how might a sustainability manager use carbon neutrality to achieve decarbonization?
I think, yeah, it kind of comes back to a little bit of that last answer in, being able to just understand the realities of the situation that you're in and be able to map that out and look at what are the highest emitting factors in your building, especially with relevance to this particular talk, or in your entire supply chain there. And I think that a lot of the clients that we work with, we find that that's a little bit of a surprising answer to where their carbon footprint is really coming from in many ways. And so sometimes half the battle is just identifying where we are. And honestly, we're still in a place, especially when it comes to the energy side of things, where it can be hard to tease this out because the data sources for understanding, for example, the carbon footprint of the energy that you're getting from your utility at any moment in time is highly variable. Some utilities offer that in a fairly transparent fashion, and some utilities don't. And so we're in this weird phase right now where you can kind of think of it where sometimes there are people that come into this space that kind of help bridge that gap, but we have to be really, really careful about the quality of that information until we have true transparency. And I think that is something that we've been kind of pushing for. And I think utilities are starting to become more and more open to the idea of being transparent about their generation sources in a minute by minute, hour by hour type of cadence. But it can be a little bit of a hard path to go down for many energy managers today, just because of the lack of transparency that can exist.
That really brings me right to my next question. That transparency, really, we hear these terms, dirty and clean energy. Can you elaborate on the fundamental differences between them? What factors or characteristics categorize a source as dirty or clean energy, and why is the distinction crucial in the contemporary energy landscape?
Yeah, and I think there's also, this is very much a gray area. I don't think you can draw a distinct line in the sand between a dirty and a clean source because there's definitely a sliding scale here. And so I think it's important to not get too caught up on trying to fully categorize something as either good or bad or dirty or clean, and more kind of understand where you're at on that cycle or on that scale, and what are the impacts of being on that position in that scale. So, I think as this slide kind of illustrates, we probably, it's no surprise to anyone on this call that a lot of the fossil fuel or driven power plants are a little more problematic in terms of their emissions. Now, there's a lot of people that will say that there's solid carbon capture approaches to some of these generation sources, and there's actually a decent amount of truth to that. But I also think we can't forget about a lot of the things that happen even before you burn certain fossil fuels. The mining, the transportation, and things like that all contribute to the carbon footprint. So I think just understanding that it is not just about the burning of fossil fuels, but that entire supply chain is something that most of us try to look at when we're categorizing a source as clean or dirty. And then you also like that, just that renewable aspect of it. And that's where you get into, I think, even more gray areas, because some people will say that hydroelectric is very clean, and other people will make the argument that, hey, building dams on rivers has very high environmental impacts. And both of those are true in underneath their own lens. And so I think that we do have a nice renewable nature to most hydroelectric situations where, evaporation of water happens, refills reservoirs, and we get this cyclic approach. But you can't underestimate the fact that it does have an ecological impact to dam rivers. And so this is where I think we get into a lot of maybe the political debate around this that maybe isn't the most useful part. We just have to accept that producing energy on a lot of fronts has impacts, and we just need to try to place ourselves in the best position along this continuum that we really can and strive to be a little bit better on that front.
Okay. All right, we have our first poll question. The poll is, have you tried or have you initiated any energy transition efforts in your commercial building? Yes, no, or we are in the process of making the transition to a cleaner energy. I'll give everybody just a moment to answer this. Okay, and it looks like we had, sorry about that, I'll share those. 43% of you said yes, you are in the process of making um, that, doing energy transition efforts into your commercial buildings. Okay. We did talk a bit about trying to define the between dirty and clean energy, but what are primary benefits of making that transition to a cleaner energy source? Obviously, knowing that some of them are, like you said, it's sort of on the line of whether there's a gray area there.
Yeah, so I think there's, this also depends on the scale of what you're talking about in terms of, are we looking through the lens of the utility making the transition, or on a more of a distributed energy source, and can you generate some of your own power on site, because they all have different advantages and things like that. And I do think that if you go more and more towards some of the distributed generation that we see happening, that you do get a more of a resiliency play in there. Now we also have to be very, very clear that having a fully resilient commercial building is not an easy cost structure to make work today. For example, like even if you can offset a lot of your power needs from like a local solar farm or something like that, there's still, and for a business to have true resiliency, you're probably going to need to go a little bit beyond that. Things like backup storage to bridge over when that solar farm is not actually dealing with things, holistically. And that is where we have a real economic conundrum today. Because honestly, lithium ion battery systems are hard to make pencil out from an economic perspective, except under certain very particular incentive structures or regulatory constructs. But I do think that we have to keep a very close eye on that, because that is the direction that things are going. And being able to make this transition from these, what quote unquote dirty sources, but that are very well understood and fairly reliable, to some of these cleaner sources that maybe have other grid dynamics that are harder for people to wrap their head around, in terms of how do we get the 24-hour resiliency and things like that. And that is the transition that we're in today, that you have to almost go market by market in seeing where the economics really make sense. And it really only pencils in many cases when people do have a very strong environmental goal within their company to add to the pure economic case today.
Are there simple steps that a facility manager, for example, can start down this path?
Yeah, I think that the obvious low-hanging fruit here is just being more efficient in the way that you're actually using energy. In our experience, when we go in and wire a building with sensors and control units and things, we can typically find anywhere between 10 and 20% of just straight efficiency using the equipment that they have in a better way, aligning it more closely with their operational parameters, finding things that are not operating at their highest efficiency, and looking at possibly replacing or repairing those items. It's very common that most facility managers or enterprise energy kind of advisors start with just, let's make things efficient and make sure that everything is operating along the correct parameters. And I think that is where you start down the path. And then, and only then, do you escalate to, okay, how can we take advantage of grid service programs that maybe pay us to use energy in more intelligent ways? How can we shift our peak usage so that we're not overloading the grid and get peak demand management relief. All of those things are kind of the stacked value that an energy management system should enable you to take advantage of. And you can start to climb that ladder from efficiency to peak demand management to demand response to other types of grid services that'll essentially be better for the grid and hopefully get you some additional revenue or cost savings while you're doing something better for the environment.
Great. I apologize. I think we skipped one. One question I wanted to kind of pull in there is really quickly before we move on to this one is what about roadblocks when it comes to these? What are some of the big roadblocks you see when going into and starting on the decarbonization path?
Yeah, I think there's roadblocks in a couple different levels. Just globally, when we look at the way our grid has grown up and what we're kind of experiencing today is that most of our processes and procedures and balancing effects were designed for very large centralized generation that essentially chases consumption, tries to match that every moment of every day. And we're in a world where that's starting to shift. And now we're getting a lot more distributed generation that's outside of that centralized metaphor. Utilities don't always have great insight into it. And we're seeing that the tools for balancing the grid become a little bit less effective in this new world where now we kind of use this term that the grid is inverting. And when you hear people say the grid is inverting, what they mean is that it's this transition from large centralized generation following demand to demand following the generation capabilities that are out there. And so it's trying to essentially flip that equation around. And what you'll see is that a lot of these programs that you can take advantage of are starting to, err more and more towards that side of things. And that's confusing for a lot of folks. It's making faster and faster response times for things like traditional demand response more and more valuable. Where before, day ahead demand response was, kind of like the de facto standard in many ways. Where now we're getting to the point where distributed energy resources can play in faster and faster response programs like sync reserve and things like that. And that necessitates systems and approaches that are much more of a scalpel as opposed to a sledgehammer in their precision and speed and how they can be applied.
Great. Okay. Thank you. Great. And next, my next question is really around how can, we started down this path. Facility manager has, started with energy efficiency, making their buildings more efficient, peak demand management, demand response, et cetera. How can they start to accurately analyze the effects of their energy transition initiatives?
Yeah, I mean, all this comes down to data and being able to change data into information. And I think if you're looking at, trying to wire your building with some type of building management system or smart system to help you with this, that it really comes down to that one thing of data to information. Because there's a lot of systems out there that can collect data about what's going on in your building, but you a lot of times have to be an expert to analyze that information and kind of scratch your head and go, well, what's really going on behind the scenes? And so what I think most people really should be looking for if they're kind of testing out different companies that may be able to help them come along this journey is really look at those higher order answers. And are those things that that a company has a proven track record of being able to provide those insights at a glance and provide the suggestions on an ongoing basis of how to improve incrementally and the observations of what's changing in their environment, because this is not a static situation. These buildings are somewhat living and breathing organisms in that the mechanics of the building shift over time, the foot traffic patterns that come through the buildings change, the climatic conditions adjust. And all this means that the data that you're collecting off of a highly sensor-oriented, wired building is going to shift and evolve day by day, week by week, month by month. And if your system is not there helping you make those adjustments, and is forcing you into the role of being an energy manager, then you're probably not focusing on your core business of making money with whatever is your business is designed to do. And I think that is really important, especially for the size of companies that are like a grid point targets, where you don't have the people that are dedicated around those roles sometimes. So we need to pour the knowledge and the insights from the algorithmic approaches to kind of mining that information, surfacing up the answers, and then providing simple, actionable, here's what you can do, click this button to make that better types of solutions.
I've picked up from you no longer saying data, but trying to talk about information and insights and
Yeah.
not just overwhelming amounts of data. So
I
thanks.
think that's super key to double down on, because so many systems out there are really good at collecting data, and the world has no shortage of data, but sometimes we do have a shortage of truly actionable information.
Absolutely. Okay. On to our next question. These are some of the obstacles we hear from a lot of facilities managers out in the field on implementing, clean energy or energy efficiency strategies into their building. Can you speak to some of these, or talk about maybe how how they can bypass some of these issues?
Yeah, I mean, most of these are like near and dear to my heart because we hear them, all the time. And I think, um, that one on the lower left where you say a lot of technical expertise is needed in this transition, and I feel for people that are experiencing that, because there's a lot of jargon in the energy industry. There's a lot of regulatory differences from one place to another, and it just feels a little overwhelming at times. And I think that is again where you go back to finding a partner that has kind of done the work of abstracting all that away. So because if you have to think about program rules and registration processes and all these things that are maybe even vary from location to location, if you're managing an entire fleet of stores, that just becomes a daunting task. And so, I think selecting a partner that has kind of done that hard work for you and basically provides the easy button of, hey, would you like to participate in demand response? Click here. Boom. And it registers you. It tells you how much you should expect to get, shows you what you need to do, talks you through any problems that you're experiencing, and your check just shows up. Like, that is the simplicity that you should really be aiming for. The one above that on the storage systems are difficult to manage and use. Like, this is something that we are really actively trying to fix going forward, because it's very true that today energy storage in the form of lithium ion or other technologies is a one-off, highly engineered solution on a building by building basis, which is great if you're a big industrial complex that can afford all of that work and make that happen. But what's interesting is that nobody has really done the turnkey Powerwall like Tesla battery thing for this mid-market. And I think once we can get all of that in place, where we can go to a client and say, based on where you're located, what regulatory incentives you have, what your building load looks like, we can drop a battery in there and we can show that it's going to give you this return on the investment. Would you like to make that happen? I think that is where the industry needs to go in terms of storage. It's not there today. There's still a lot of regulatory hurdles in terms of fire codes and siting and other types of regulations, but you're starting to see that consolidate, and you're starting to see companies start to build more and more repeatable packages. And I think you're going to hear a lot of movement on that in the next year or so. You're certainly going to hear it from GridPoint, and I would imagine there's going to be a lot of other companies trying to follow that same path.
That's great. That's really exciting to hear. Definitely excited for for the future there. Any more of these that you would like to touch on?
Well, I think that the clean energy is intermittent and unreliable. It really goes back and kind of emphasizes one of the points that we talked about earlier, which is just this whole concept of needing to have a mental shift of, instead of the generation following demand, that the demand starts to follow generation to some capacity, whatever we can. So we invert that around so that when there is an abundance of solar or an abundance of wind, that we can maybe pre-cool buildings or charge our storage systems or run intensive processes that need a higher level of energy. And then we can make intelligent decisions about backing off in the same vein when either the mixture of power turns to a dirtier source or when it's just less available. And so being able to, mix and match and delay and accelerate the consumption of power, I think is going to be more of the norm going forward, where we've just kind of used power whenever we wanted before, which was great. But I think there's going to be financial incentives more and more to change that behavior. And we've already seen it, especially in the residential markets with time of use rates and things like that. And those are very crude instruments for guiding people to using energy in certain times. You're going to see those become much more refined, or more real-time pricing, more very dynamic nature of things.
Great. Thank you, Mike. All right. We will move on to our next poll. What do you consider to be the biggest roadblock when it comes to beginning to decarbonize? Apologies, I will go. Okay, there you go. It is up on the screen. I'll give everybody just a moment to answer. Hey, it looks like cost to implement was our number one reason, our biggest roadblock when it comes to decarbonizing buildings. That's an interesting one. Do you want to touch a little bit on anything about GridPoint's subscription model and how we just do that real quick?
Absolutely. And I think we hear this from our clients all the time, a lot of times when you come around to capital expenditure planning, energy is not the number one thing that comes up when you're trying to allocate rare capital. And that's totally understandable, and was something that we heard from our clients time and time again. And so, what we did was we took that entire issue off the table by essentially allowing this all of the hardware and installation processes that need to go on to wire a building and turn it into a smart building, essentially take all that upfront costs away, roll it into a low monthly fee with a financing instrument that we've got already set up, so that our clients can basically just sign on the dotted line and say, hey, I want to be revenue positive from day one with GridPoint's solution. Can you make that happen? And we're like, yes, we can. Even with the financed hardware to make your building smart, we can actually start from day one and get immediate cost savings, and you don't have to write that check to make all that happen, because it's the same message that we hear time and time again from people trying to make hard decisions between investing in your core business versus investing in what might be considered a tangential benefit of using energy in a better way.
Thank you. I promise that's the only sales pitch I'm going to make you give today.
Hopefully it's still relevant.
It is. Well, it was kind of our next question anyway. How can facility managers keep their costs low while still meeting goals for decarbonization?
Yeah, I think that's we definitely touched on this. Although I do think that you you can keep costs low by not spending money, or you can keep costs low by also bringing in additional revenue sources. And I think that is super important to remember, that this is a stacked value problem. Just because you've kind of cracked the energy efficiency side of it and you're using less power doesn't mean you're at the end of the journey. And being able to take advantage of other revenue sources, that you should be able to do very easily with a click of a button. And we've mentioned a few of them: peak demand management shaving, demand response. All of those things are ways of capturing additional revenue that can make this daunting cost structure much more approachable. And if you've got a partner that is not talking to you about this stacked value, definitely look for another partner, because that is really the long-term goal in this journey.
Absolutely. Great. Thank you. All right, moving into sort of our next section, talking a little bit more about the hardware. How can IoT-enabled devices assist in expediting the journey towards decarbonization?
Yeah, there's been a lot of exciting technology stuff that has come about even in the last few years that have started to enable a lot more nuance in this problem. And I think one of the biggest things is just the very low cost sensor and control units that were required a lot of infrastructure or communication costs just 5 or 10 years ago. And today the communication costs have gone to near zero if they're done correctly. The size and energy consumption of these sensors and control units has gone down every year. And the ability to install these in a very fast fashion, heavily reliant on wireless technologies that can make a building essentially a nerve center without going through the brain damage of pulling a bunch of extra cabling and all the things that may be problematic, whether that be just because of the time and money it takes, or because it's an architecturally significant building and you don't have access to making those types of modifications. So I think that all of that all of that new wireless technology that is coming about as being driven by the IoT revolution has really started to make this approachable for the mid-tier. We've always been able to do this in the large industrials. There's enough money involved in those types of places that you could really do whatever you needed to do. And most of the solutions that have been available in the last 10 or 20 years have been very focused on that very high-end part of the market. IoT has really democratized this and has taken that percentage of buildings that are out there, which are huge, like the number of buildings that, kind of in this space of small to medium-sized commercial is staggering. And so our thesis on this is, as we can bring these principles and practices that were established in the large industrial world, automate them, take cost out of them, and just drive them further and further down market, that I think it's a huge benefit of what we've seen in the hardware evolution of things.
Absolutely. Thank you. Okay, our final poll. What smart technology does your building currently utilize for energy monitoring or control? You can check all that apply. All right, I'll give everyone just a moment to go ahead and answer that one. I think another conversation, Mike, is going to be the difference between an energy management system and a smart thermostat, because I think there's still a lot of confusion in the market on the two, unfortunately.
Yeah, that's another one of those gray areas where there's no one exact delineation point, but it's super important to kind of understand what you get with one or the other.
Mhm. All right, I'll give just another minute. All right, it looks like the energy management system, we had 86% using that, 71% using the smart sensors, excuse me, and 57% using smart meters, and 43% of the audience using smart thermostats. It's good to know.
Yeah.
All right. how can a facility manager harness the data analytics to speed up the process of decarbonization? I know we touched on this a little bit in the beginning, talking about those actionable insights. Is there anything specific that they can do to just to make it go faster and increase that?
Yeah, I mean, I think we can dive into a lot of particular use cases here, but one of the classic examples that we see time and time again going into this particular part of the market is that there's actually problems with things like HVAC units at a lot of buildings, and people don't even necessarily know that that's happening because maybe they aren't in a place where they're actually failing, but they're actually operating really, really poorly. And this is where I think one of the differences between, I think, a smart thermostat and a true energy management system really comes into play. Because if you have a real energy management system that has a wider array of sensors around it, you can determine things like HVAC health just by observing how things are operating. And you can see that trending over time and maybe make a decision of when you need to step in and schedule service in a more proactive fashion. Because let's face it, a lot of times companies will let that go until it becomes a very critical, like, hey, it's not working type of problem. And that runs into, business continuity problems. But well before that happens, there's already signals that you are wasting power or not using things the most efficient way. And a good energy management system is going to give you those insights before they become critical. And again, it's that data to information thing, because we will see the supply air temperature shifting over time. We'll see the runtime creeping up under similar climatic conditions, and we'll see those trends. And as soon as they cross a threshold, you need to be proactively alerted that, hey, something is going wrong, and we think you're at a point where it would be more cost effective to have a technician come in and fix this problem than just paying to operate an inefficient piece of gear. And that is way more common than you may think. And it goes beyond HVAC. We see it with refrigeration units. We see it with all kinds of other machinery within different types of buildings, that they aren't always operating well, and people don't even know that that's the case until they reach a critical failure, and that's too late.
I will put in one more plug for GridPoint on that. We have quite a bit of information about the differences between proactive, preventative, reactive maintenance on our website, gridpoint.com, if you would like to go read more about that as well. All right. We're going to end with just a quick look at what one of our customers was able to do, and Ampler King was able to do with GridPoint Intelligence. They had over $4,000 in savings per location per year, and a 21.6% kWh reduction in energy usage per month. So just a quick case study from GridPoint on that. And with that, we'll wrap it up with a couple of key takeaways here. My slides are, yeah, doing great today. All right, a couple of key takeaways. Mike, did you want to touch on a few of these quickly before we move into questions?
Yeah, I think the data analytics is just near and dear to my heart. I feel like, every industry in the world is moving towards a data-centric view of what makes them, unique and can kind of move the needle. And having been in the energy space now for a little over 15 years, I thought that this process was going to come about a little bit more quickly than it has. But I think we're finally in that place where people are starting to, we've got enough sensors and control units that are out there, and we've got the data coming in, and everybody's like, okay, now we can really turn this into a true analytics solution. And I really harped on that data to information evolution, but I think there's actually one more incantation of that, or one more evolution of that, and taking from data to information to finally to action. And I think that is really probably the key to any good solution here, is not just surfacing those insights, but closing the loop so that either a human is in there still saying, yes, I want you to make these changes, but go ahead and make it and just make it happen, or even taking the human fully out of the loop. And just once you've built up trust and intuition in the system so that we can notice these problems, we can auto correct them and take that chain of data to information to action and just make it a closed loop cycle. So it just continues to get better and better and better over time.
A lot of that's part of that preventative maintenance as well that we were talking about too. So,
Absolutely.
all right. We will move in. We do have a few questions. So our first one is, what are the most immediate steps businesses can take to start implementing towards decarbonization? I know you touched on the energy efficiency. Is there anything specifically within there? I'll make my third plug for GridPoint and say, just give us a call and we'll handle it for you. Is there
Yeah.
anything else you want to expand on that though?
Um, I do think that, especially if you have the ability to engage with, an energy engineer and, kind of do a little bit of an audit of what's going on within your particular environment. But if you look at the types of customers that GridPoint tends to specialize in, we tend to see very repetitive solutions. And that's great, because it means that there's, a market that can be addressed there. And so don't think that, you're have the own like a solution that is completely unique. Everybody is experiencing very similar problems. And I think half the battle is just trying to learn from what other people have done. And that's what we've tried to do with our platform, is just pour all of that knowledge back into the platform so that the things that we've learned, that our customers have learned and tried, it now becomes just an automated solution and an automated insight into how we can make things better.
Great. Okay, thank you. Our second question is, does GridPoint provide analysis to decide if it's worth joining or exiting the utility peak pricing scheme?
Mhm. Yeah, I think that's one of the interesting things that you see in different utility programs, whether it be peak demand management or demand response or other things that or time of use rates, is that they don't always line up. And you would think that they would all like crescendo to create the same behavior. But what's interesting is when you look under the covers, a lot of times there's a little bit of mismatch there, and there's opportunities for essentially arbitrage of which programs do I want to take the flexibility that I have in my building and apply it to that. And a good energy management system can understand and figure that out in real time and dynamically shift to doing different types of solutions based on the places you are, the programs you have access to, and the way your building actually behaves. And so it is not a one size fits all solution. It is a situation where you need to have a system that is constantly reevaluating what's going on and how can you squeeze a few more dollars out of that limited flexibility you have, because we can't push and pull on everything. You've got a business to run, and that business has a baseline of need there. And so if it's only a tiny fraction of the load that we can actually move around, we want to move that around for the most significant economic advantage we can get for our clients. And that comes down to a lot of data science and machine learning type of algorithms that can do that for us, because we're doing this at scale. This is not a human oriented problem. We need to have machines that can figure this out and make those suggestions in real time.
Great. Well, Mike, I want to just thank you very much for taking the time today to explain a lot of this to us. This does conclude our webinar today. When the webinar closes, we will, like I said, post this onto our website for you to take a look at. All right, Mike, thank you again.
Thanks a lot. Have a good day.
Thank you. Bye.